Hello, my name is Amelia, and in this video, we will be talking about game theory. But first, let's talk about commuting. You drive and are deciding when to leave for class or for work. If everyone chooses the same perfect time, the road gets clogged and your commute stinks. If some people shift earlier or later, traffic eases and the commute isn't so bad. What makes sense for you depends on what everyone else decides to do, even though you never see their plans in advance. That's basically the feel of game theory. Your outcome doesn't just depend on your own choice, it depends on other people's choices too. So, we will be using this website to connect situations like that to formal ideas and how the same logic shows up in markets, negotiations, and finance in general. All right. So, what is game theory? Well, game theory is a mathematical study of strategic decision making, like how rational decision makers choose actions when their outcomes depend on other players' choices too. John Nash, he was a mathematician who contributed a considerable number of concepts toward game theory and its applications to various sciences. One of his insights is that the best result doesn't always come from each person blindly maximizing their own payoff. Sometimes pure self-interest hurts the group and even backfires on individuals. So you'll kind of see, his famous little quote here. I mean, essentially, that gap between what's best for me and what's best for us is where game theory lives. So if you scroll down, the four building blocks are players, strategies, payoffs, and information. Here you could read about why game theory matters in finance. And here's some of the types of games that will help you classify situations by timing, information, repetition, cooperation, and whether the game is zero sum or not. And so let's move on to the prisoner's dilemma. This is the most famous game in economics. Without any sort of communication, two suspects must choose whether to stay silent or betray. So this payoff matrix shows that if both suspects cooperate or stay silent, they each get light sentences. If one defects while the other cooperates, the tattletale goes free, and the one who stays silent faces the consequences. However, if they both tell on each other, they get moderate sentences. The finance version is a price war between two fintech firms, choosing whether to keep prices high or not. So here's that matrix that you can look into. So down here, you can actually play 10 rounds as suspect A against a computer using a mixed strategy. And so the goal here is kind of to see your own instincts play out and to feel how repeated interaction might change your behavior. After 10 rounds, you'll get a score that will give you an explanation. So, yeah, I mean, like, let's just do this really quick. So, like, here's your score versus the computer. There's your label. And you can read more about the different strategies down here and real world prisoners' dilemmas. A Nash equilibrium is a set of strategies where no player can improve their payoff by changing their own strategy alone, given what everyone else is doing. Basically, each player's strategy is their best response to every other player's strategy. And since no one has any incentive to deviate, the system is then in equilibrium. And the key insight here is just don't mistake best response to each player being happy with the outcome. And so you can read more about how to find Nash equilibrium here in this section. And here there's an interactive Nash equilibrium finder. where you can enter in numbers and then find the Nash equilibrium, basically. It lets you experiment with your own payoff structures, essentially. Down here is the different strategies. So like, for example, dominant strategy, it gives the highest payoff regardless of what the other player does. So like in the prisoner's dilemma, defect is a dominant strategy. And that's why mutual defection is so robust. Here is the dominated strategies, where any other strategy will always do better, regardless of what others do. And then here's the mixed strategy, Nash equilibrium. It's where players are indifferent to their choices, so they randomize their strategy, like in rock, paper, scissors. So this tab gives you more information on classic games beyond the prisoner's dilemma, each with a payoff matrix, an intuitive story, and a finance application. So you could read more about each example: Game of Chicken, Battle of Sexes, and Pure Coordination. Each example highlights that multiple Nash equilibria can exist, and that the challenge often isn't finding an equilibrium mathematically, predicting which equilibrium real players will coordinate on, like through norms, law, focal points, or market power. So here's a useful table that dives into real situations and categorizes them into the different game types that they most resemble. So auctions are actually one of the most direct applications of game theory in finance. And so here are the different auction types. English is the one that I think we're most familiar with, where bidders openly raise their bids until no one is willing to bid higher, and the highest bid wins and pays its bid. The Dutch auction is where the auctioneer starts at a high price and keeps lowering it until a bidder accepts. So the first person to say yes wins and pays that price. First price sealed bid is when each bidder submits one secret bid, and the highest bid wins, and the winner pays their own bid. And the second price sealed bid is when each bidder submits a secret bid, but the player pays the second highest bid instead of their own. For the winner's curse, an example is actually in mergers and acquisition, or M&A, where the winning bidder pays more than the target is actually worth. Mostly because of competitive pressure and over-optimism, which push their offers above true value, turning winning deals into long-term losses for shareholders. And then with this tab, I mean, game theory and finance, market interactions are full of games, which makes it so important to understand the strategic structure of finance. Here you can read more about the types of competition and a couple examples that occur between firms. Negotiation theory is centered on knowing where your disagreement point is. Down here is a perfect example of a network effects game between Venmo and Cash App, when value increases with the number of users and fee cuts create a chicken race to zero that forces platforms to pivot to new revenue models. All right, and so this is actually really interesting. So behavioral game theory shifts from strictly rational players to real humans. And humans often deviate from Nash predictions. So here is the ultimatum game. So player one proposes how to split a fixed amount of money that's been given to them. Player two can accept. If they accept, both players get the proposed amount, or they can reject, which leads to them both getting zero. Let's go ahead. So the proposer offers you 33 and keeps 67. Which one will you choose? Accept 33 or reject? So both of you guys get 0. I'm going to go ahead and reject. And so here's basically an explanation. So standard game theory predicts that player 2 should accept any positive amount, and player 1 should therefore offer the minimum amount possible. However, in real experiments, whenever proposers offers anywhere around 30%, the responders usually reject in order to punish unfairness. Just, something to think about. So here you can read a little bit more about how humans deviate from Nash and why these behavioral patterns might explain why job candidates reject lowball offers, even when unemployment is the alternative, or even on the flip side, why firms that treat customers fairly during crises, they earn a disproportionate amount of loyalty. So for the next tab is a tournament. You can play games to determine what your strategic profile is. Like, are you a Nash rationalist, a cooperative strategist, or a behavioral player? And finally, if you want to do some homework, here's 15 questions that you can answer just for you to test your skills, essentially. And that's really it. That's game theory. And I hope you enjoyed this video. Thanks for watching.